Lesson 10.6, Calculus of Polar Curves. In this lesson, we're going to take a more in-depth look at areas, in particular area between polar curves. We're going to find the area of the shaded region of one polar curve, and then we're going to find the area of the region of another polar curve, and we're going to subtract them. And when we subtract them, we get the difference, which is what we're looking, the area between the polar curves. We can condense the formula, and it looks like this. Let's go ahead and try this problem. The first idea is to try to find where the two curves intersect, and we're going to do that by setting the radii equal to each other. So cosine of theta will be equal to 0, and so theta is equal to pi halves, and that's what we see right here. We're going to represent a little piece of the area, which is 1/2, the radius sub 1 of one of the polar curves minus the radius sub 2 of the other polar curve times delta theta. In this particular case, the larger radius is the circle with radius 1 minus the cardioid, which is 1 minus cosine theta quantity squared delta theta. Now I'm going to go from 0 to pi halves, and that'll be this area, but I'm going to double it to figure out this whole area. So this will be 2 times integral from 0 to pi halves times 1/2, 1 minus the quantity 1 minus cosine theta quantity squared delta theta. And from here, you just use your calculator. All right, let's take a look at the area between this circle and this circle. So it means finding the area of the whole circle here and then the smaller circle. But again, we want to start off with where do they intersect. And so we're going to set the two radii equal to each other, which is 2 cosine theta equals 1. So cosine theta is equal to 1/2. Theta will be equal to pi thirds. So this is where they're going to intersect when they both have an angle of pi thirds. I'm going to find the area right here, the area of the subtraction right here, from 0 to pi thirds, and then I'm going to double it to get this area that's underneath. So a little representation of area will be equal to 1/2 the larger radius, which is the this one over here, which I'm going to square, 4 cosine squared theta, minus I'm going to square this radius, 1 delta theta. So my area will be equal to twice times 0 to pi thirds, 1/2, 4 cosine squared theta minus 1 delta theta. All right, let's find the area of this shaded region. The area of this shaded region is different from the last two examples. We are not subtracting areas this time. In fact, we're taking a look at areas. I'm going to take this region, I'm going to blow it up a little bit. And so I'm going to, here's the x-axis, and in one color I'm going to show you that part of the boundary is the circle, and then the other boundary right here is actually the petal. Let me go ahead and draw a straight line for you. So from here to here, and I'm going to do it from here to here. So these little sectors that we're going to have, their edges are going to be different radii. All right, so let's figure out a little piece of area for this first portion that's using the circle. So that's going to be 1/2 r squared delta theta, and in this particular case it's the circle, which is going to be 1/2 squared delta theta. The other little area that I'm going to be looking at is going to be from here, this area, which is using the rose petal. So this is going to be cosine 3 theta quantity squared delta theta. Now it's going to be important that I find where these meet, so I'm going to set the two radii equal to each other. And then this is going to be, this is going to take place when theta is equal to pi thirds, or I'm sorry, pi ninths. If I put pi ninths in here, then I'm going to get pi thirds. This whole quantity will be pi thirds, and then I'll get the 1/2. So this point right here is when theta is equal to pi ninths. Now the next question is, when will this petal get down to the center? Because I need to find the area from pi ninths, and I got to figure out that. So I'm going to set the petal cosine 3 theta equal to 0. And that'll take place, the first time that'll take place is when theta is equal to pi 6. Now how do I know that? If I put pi 6 right in here, then that'll be 3 pi 6, which is pi halves, and I know cosine pi halves is 0. So right here is where theta is equal to pi 6. Alright, so let's go ahead and find the area. Remember, this is doubled. So our area will be equal to 2 times, and I'm going to find this area right here from 0 to pi ninths of, and then this looks like it's just 1/8 delta theta plus 2 times, and I'm going to go from pi ninths to pi 6, and then I'm going to use this area formula, which is 1/2 cosine of 3 theta squared d theta. And this will give me the area that I'm talking about there. Okay, last problem, we want to find the area of region A, and this is a subtract situation. Let's go ahead and set the r's equal to each other. This is 4 cosine theta is equal to 1. So cosine theta is equal to 1/4. Theta will be equal to cosine inverse of 1/4, which is about 1.3181116072. So I'm going to let P be equal to that number, 1.3181116072. And so that's our P. So our theta is equal to our P. Alright, so now what I want to do is I want to set up a little piece of area, and a little piece of area will be 1/2, and my outer r is 16 cosine squared theta, my inner r is 1 squared, and then this is delta theta. So my area will be equal to 2 times, I'm going to find the area from 0 to P, and then this will be 1/2 16 cosine squared theta minus 1 d theta. And this is the end of the broadcast.